So today I'm going to be talking about experiment 6. So part A focuses on acetic acid and acetate. The acetic acid was clear and the acetate was also clear. And the significance of the first pH measurement is to offer comparison for the next recorded pH. And the pH level of 0.1 molar acetic acid was 5, and that made it more acidic. And from there, we're able to compare the next pH level of when sodium acetate is added. So when sodium acetate was added to the solution, it had like a higher pH level compared to that of the 0.1 molar acetic acid. And sodium acetate's pH level was a 6, making it basic or more of a neutral solution. And the stresses in this experiment was adding in sodium acetate as a reactant. And down here is the balanced chemical equation when the sodium acetate was added. And to reestablish equilibrium in the equation, it's going to shift right because 1 gram of sodium acetate was added to the reactant side, meaning that there are now fewer products compared to reactants. In order to counteract this, the equation is going to shift to the right, so there will be an even amount of products and reactants. Part E focuses on iron and iron thiocyanate. Fe plus is like a pale yellow, SCN is clear, then FeSCN plus 2 is like an orangish blood red color. So the color of Fe plus is a very pale yellow. SCN was just colorless, making it clear. And FeSCN plus 2 was an orangish blood red color. When KSCN was mixed with FeNO3, it shifted into a more orangish blood red color, just more saturated, almost a bit more red. And when heat was added to the solution, it turned into a darker red. It was almost black and just a little bit cloudy. And this reaction is endothermic because heat is a reactant. And this is evident because when heat was added to the solution, the color got darker, almost like a blackish color. And if the reaction was exothermic, the color would get lighter. But since it's endothermic, the equilibrium will shift to the right to reestablish equilibrium because heat is acting as a reactant. Therefore, there's going to be less products. So the equation is going to shift to the right. When 1 molar of FeNO3 was added into the third tube that held the mixture of KSCN and FeNO3, it became more of an orange color, so lost that tint of red to it. And when 0.1 molar of KSCN was added to the solution mixture in the fourth tube, it became like an almost black color. It could have been like a very dark red, but it looked almost black. And right here is a balanced chemical equation when AgNO3 is added into the mix. And after AgNO3 was added into the solution, this would make everything shift to the right to reestablish equilibrium because AgNO3 is getting added to the reactant side. Therefore, it needs to shift to the right to counteract that. And part F focuses on bicarbonate carbon dioxide. And right here is the balanced chemical equation. So CO2 was removed by aspiration because it was the gas produced by the reaction. And because there was a suction present, meaning that the gas will be removed, and this will cause the pressure to increase. And during the experiment, the suction applied caused CO2 to be removed from the flask, and this stress decreased the levels of CO2, which forced the other product, OH-, to increase to keep the reaction at equilibrium. And this increase caused the color change of the solution because OH- made the solution more basic. And bases occur in a pH greater than 7. And according to the lab manual, when pH is less than 7, the indicator will cause the color to become blue. And this equilibrium is going to shift to the right to produce more products to counteract the loss of products.